let's talk about the shapes of distributions. That's going to be the shape that our data takes on. Specifically when we graph it, mostly using histograms. So if you don't feel comfortable with graphing or interpreting data from graphs, please go back and take a look at section chapter 3. Here's our book goal and our course objective. So because we are interested primarily in the general shapes of distributions, it's often easier to examine graphs that show smooth curves rather than the original data set. So what we're doing is we're taking our original histogram and applying a graph to it. These smooth curves are used to approximate the shapes of distributions. So, from these shapes of distributions, we can discuss the number of modes. So for example, if I have a graph where so this is, remember, it's the frequency on our y-axis versus whatever that data value was. And this, we've got a constant value, so there are no modes. Here, this value occurred the most frequently, so we have one mode. Here we have two modes. Technically, those should be even, but it's important to note how many large groupings of numbers there are. So for example, D has 3 modes. A symmetric distribution called a normal distribution or a bell curve, right? That's a distribution is symmetric because its left and half is a mirror image of its right half. So here are some different symmetric distributions. This is the one we're going to see the most, that normal curve or bell curve. Distributions can be left or right skewed. A left skewed data means our mean and median are less than the mode. That means our outliers are to the left, they take on low values. So if we were to sketch it, our hump is on the right. So I kind of remember that left and right skewed are opposites. If I have a right skewed, that means that my median and mean are less than the mode. So our outliers are really high values. That pushes our hump, our concentration, to the left. And in a symmetric distribution, the mean, median, and mode are always the same. So for each of the following situations, state whether you expect the distribution to be symmetric, left skewed, or right skewed. So one thing I want to say first is that naturally occurring data tends to be normal. So let's take a look at A. If I'm looking at the heights of a sample of 100 women, proposedly randomly sampled women, this would be symmetric, right? We'd expect that to fit a normal curve, but most people would be the average height of women, which is 5'4", 6, I can't remember. Family income of the United States. This is something I've made a lot of TikToks about. I'll make a compilation for you guys and put them together. So, family income in the United States, right? Let's take a look and see what we think. So, we've got outliers. We've got people like Jeff Bezos, who owns Amazon, and Elon Musk, who just surpassed him. He owns Tesla, right? And those data values are skewing our data to the left, to the right? This is right skewed data because our mode is going to be less than our mean and our median because these outliers, these outliers are really affecting us. So this is going to be right skewed. Next, let's talk about example C. So, when we're looking at speeds of cars on a road where a visible patrol car is using radar to detect speeders. So, when I am driving, I always drive really slow, let's be completely honest. But a lot of people, when they see a police officer, slam on their brakes and slow down. So that means we're going to have some outliers. We're going to have some really slow people we're going to have most people, right, going the mode speed, which would be closest to the speed limit. Some people are going faster, most people are going slower. We have some outliers. So this would be left skewed. Next, I want to talk about variation. Variation describes how widely data are spread out about the center of a data set. So if I have low variation, my data is really concentrated close towards that mean median mode value. Moderate variation, it's spread out a little bit, and high variation, it's spread out quite a lot away from that middle value or average value.